In these two examples, we're going to be doing some antiderivatives of trig, and they're going to be some use substitution problems. So, big thing about trig is remembering that when we talk about use substitution, it had to kind of come from a chain rule type of a problem. And all trig problems are chain rule types of problems. So technically, they could all be undone with use substitution. The trick is to figuring out which piece is your u. And so back up here on these two examples, or even the examples before that, this is that inside piece that when we do our chain rule, that's what we're setting our u equal to. So we're always looking for, if you can do the derivative of this, do you get this, right? Derivative of an x to the fifth is an x to the fourth. Derivative of this quadratic would get us a 2x plus 5. So we're matching that. That's kind of always what we're looking for. So on a straightforward kind of a trig problem, this is your inside. This is your chain rule piece. And so we would let our u equal 2x, our du would equal 2 dx. And then I'm always just going to bring that piece over. So that's going to be a 1/2 du equals dx. So dx is being replaced with a 1/2 du. So this becomes, I'm going to take the 1/2 out in front. And then it's now, instead of cosine of 2x, it's cosine of u du. Right? So the reason we do this is now I don't have any kind of a chain rule applied to it. So I just do my antiderivative of cosine, which I don't have memorized. So I start thinking of, all right, I start going through the chain. Derivative of sine is cosine. And then I don't need to keep going because I'm sitting at cosine and I'm doing the antiderivative of it. Sometimes I can't, I need to go further out, like derivative of cosine is negative sine, and then just kind of keep on going. It'll cycle all the way back around and just kind of see where I'm at and then pull it back to do our antiderivative. So the antiderivative of cosine is sine. So we're looking at a 1/2 sine u plus c. And then I'll replace my u with 2x. So 1/2 sine 2x plus c. And that should be my answer. So I'm going to check it real quick, just double check. If I were to do the derivative of this, I would be doing the chain rule. So the derivative of the outside, derivative of sine is cosine, and then 2x, and then times the derivative of the inside. And the derivative of the inside is 2, which would cancel away the 1/2, and then I wouldn't have any values in front. All right, now this second one, trickier. First thing, no matter what that I'm going to rewrite this as, is I don't love that. It just doesn't make it seem as obvious of what's going on. So when I have a cosine cubed, I have a cosine cubed, is the way that I think to rewrite this. So my choices are either I'm going to let my u equal sine or my u equal cosine, because the derivative of sine will get cosine. The derivative of cosine with a negative sign, but we'll get sine. But it's this piece that screams that this is my inside piece, which means my u is going to be the inside piece. My u is going to be the inside piece. My u is going to be the inside piece, right? So u always is that inside piece, and this is a lot more obvious that that's the inside piece. So my u is going to be cosine x. Du is going to be negative sine x dx, which almost perfectly matches. So let's bring the negative over. So it's a negative du equals sine x dx. And there's our perfect substitution. I'll rewrite this by pulling a negative out of the whole thing, which is that negative right there. This is our inside, which we're going to rewrite as u to the third. Sine x dx is being replaced with the negative and then the du. And that's what we're doing our antiderivative of. So antiderivative, we'll keep the negative flowing through. U will add our power, divide by our power, and then plus c. So our antiderivative is negative 1/4. Where are we at? Our u was cosine. So cosine x to the fourth power plus C, right? One way to write it, or if you would rather, negative 1/4 cosine of the fourth x plus C, whichever version of that you're more comfortable with, but technically they're exactly the same. All right, so that was doing two trig values. Trig problems are always a little trickier than the non-trig ones because just kind of recognizing which is your inside piece, which is your outside piece. But I think just that little bit of rewriting, if you don't have anything else going on, that definitely is your inside. And just by rewriting a little bit makes it a little bit easier to see what your inside piece is.